Okay, so we are going to start with our lab session. All of you have installed MATLAB or you have access to MATLAB online?
Both.
Okay, both. So, because today's session is not going to be about a particular program, because अभी तक हमने कोई particular model class में study नहीं किया है, तो next lab से तो हम formally particular models को सॉल्व करेंगे और उनका न्यूमेरिकल एनालिसिस करेंगे बट इस लैब में हम कुछ जनरल डिस्कस करेंगे एंड दिस इज ऑल्सो समथिंग विच यू हैव ऑलरेडी स्टडीड so you all have studied the course of this numerical analysis, right? So I'll be just asking you a few things and from that I'll get some idea. Okay, just give me 1 minute. I'll just connect my writing tablet. Okay, so I'll be just writing the few things. You might have already studied this. Are you familiar with this curve fitting? Okay, let me first just explain something and then I'll be asking you. So basically, the process of modeling which we do, in that we formulate the model and then we have a mathematical expression and then we solve it and then we solve means by analytic means we can also have its exact solution or we can also solve it numerically. So it depends upon the model to model. Just a minute. Yeah, so it depends on model to model. Some models we solve analytically and some we solve numerically. And then we say that whatever answer you are giving, whatever answer your model is giving, so you validate the solution. So how you are going to validate it? Hello? Are you able to hear me?
Yes,
Yes,
ma'am.
ma'am.
Okay, okay. Yeah, I think I just lost the connection for a minute. Okay, so normally this is the process which mathematical modelers follow. We formulate the model, we solve the model, and then we validate the solution. By validation, we mean that we'll study this validation process in theory also, but I'm just giving you some idea. So validation means you need to compare the values with experimental values, or you can say you make a comparison with the real data for some problem for which real data is already available. So it may not be possible for every problem real data is available, but for some problems, for many of the problems, we have the real time data available. So we can test our model on that data and then we can make a conclusion that whether our model is accurately predicting the real values or not, or what is the difference. So this is a general way of doing the things, while there is an altogether different approach which is mostly applied by the persons who do not do the mathematics part first. They follow it in a reverse way. So they first have the data from the experiment. So I cannot say about other things, but many of the mechanical engineering people I have seen use this technique, that they already have data. Some of whatever experiment they are conducting, it might be from their lab. They are measuring some uh, pressure, they are measuring the temperature or whatever. They are measuring the flow, flux, how much fast the particles are moving. So whatever, it really depends upon what particular thing they are modeling. So they have some data with them, and now they want to find a mathematical expression for it which fits that data. So you see the contrasting difference. This is a technique followed by us. Like, we start from the mathematics, we solve it. Obviously we start from the real problem first, and based on that we formulate a problem mathematically, and then we come to the data validation. But sometimes in many of the techniques, this technique is used, that we start from the data, and then instead of finding the equation first, we try to get that equation directly by looking at the data, that what is that curve or what is that function which is going to fit this data. And then we get the mathematical model, and then we discuss it, then we study it. Okay, why the behavior is exponential, or why the behavior is like that. So I'll just give you another example here. So if you take this example of COVID-19, so far nobody has been, or I should not say nobody, many people are working on the mathematical modeling of it, but no one has exactly come up with a precise explanation mathematically that how this is happening, or no model is yet proving to be that much efficient, right? So the people who are using this technique, that they are getting the data. So this data is available. The data for COVID-19 is available on many data sources. So on the website of WHO, or there is another website, you might have checked it while looking at the data of this COVID-19 if you are interested. Otherwise, you check this one, Worldometers. So it has a huge database, country wise and everything. So this has all the data for this, how many infections are coming up each day and so on. So then you want to fit a model to that. So there we use this process, curve fitting, that okay, we already have the data points, we want to fit a curve into it. So that is basically the meaning of curve fitting. And this is something you have already done in your numerical analysis. So I will ask you here, so tell me the exact tell me the topic which told you or which explained you the similar things there in NA. What was that thing which was related to this? Yes, anybody can answer. I'll just again simplify the problems for you. Say you have, wait a minute.
Can you repeat the question?
Yes, I'm going to repeat the question. Let me just go to the, okay, here it is. Okay, the question says you have the data points with you, some random data points. Data points means it's the data is like this. This can be time, that at this much time, this much is the number of, say, infected people. So this time can be anything. This can be a day, this can be a month. So it depends upon the unit of time which is used in the data. So you have data points with you, like randomly scattered. This side of the graph you have time, this side is whatever is your measuring quantity, whatever quantity you are measuring, right? Say this is a graph, so these are the points you have. So now I want to fit a curve into this data. So how do we do that? That's the question.
Regression models.
Yes, you have regression models, and what else? What, okay, what is a regression model? What, on what concept it is based?
Ma'am, we see the data points and then fit a curve on that data points. Like there's a linear regression model,
Yeah, so in
then
linear
there's a
regression model, you fit a straight line. Yeah, yeah. So that's basically curve fitting. Depending upon
Yes, ma'am.
what curve you want to fit, So you can fit a straight line. So suppose you want to fit a straight line here, say it will be like, I just fit a straight line here. Obviously, because there are more than 2 points, so I cannot draw a line which can pass through all the points at the same time. So there is a unique straight line existing which fits this data, right? But actually you can see it is not fitting it because it's not going to happen because the points are not collinear. So on what principle this is based, that how do I know that which line should I choose which should be closely fitting my data, or which is a approximate representation of my data? So that is based on method of least square, that you compute the errors. So this is the error, like this is the error, this one is the error, distance of the difference between the real value and your value, means whatever is predicted by your straight line. It's like this, yi, suppose this is a real value, this point minus yi hat, say this one is a predicted value. So you take that difference, and then what you do, you square it. Because why do we square it? Anybody can answer that? Why do we square the error? This is error basically. Say that again.
मैम नेगेटिव और पॉजिटिव दोनों हो सकता है.
हाँ, दोनों को कवर करने के लिए, because we don't want to consider the magnitude of sign of error to play any role over here. We just want to look at its magnitude. So एक तरीका होता है mod लेने का, absolute error, और एक तरीका होता है square करने का, so that you get rid of the sign of the error. So square you do, and then you take the summation, I is 1 to n, whatever be the n be your number of total data points, and then we minimize this. So that was method of least square. So this is what you have already studied. और इसको minimize करने के लिए हम क्या करते हैं, इसका derivative लेंगे as a function, because it's a function of your I, it's a function of x. So you take its derivative, and that will give you equations, and from there we get the values of these. We assume that, say, y is equal to ax plus b. जो हमें fit करना होता है straight line, we assume it should be of one kind. So obviously this is the equation of a straight line. So we want to know what a and b should be there so that the error is minimum. So we take it like this and substitute it here. So okay, I'm not going to explain that, but that's the basically thing which is followed after every regression model. So it's a linear regression model, so it's like that. And then there are multiple regression models, so they are generalizations of this method only, but the basic always remains the same. So that's the basic idea of curve fitting. You are fitting a straight line. Similarly, you can fit a polynomial, and you can fit exponential curve, whichever. So this was a theoretical thing, right? You were given this option in those kind of questions, that okay, you fit a straight line. Now suppose you are not satisfied with this fit, and somebody asks you, okay, fit a quadratic polynomial over here, then also you do repeat the same procedure and fit a quadratic polynomial. So who is going to tell you, means what is that quantity which will tell you that which fit is better, whether a linear was better or a quadratic was better, or even a cubic polynomial would be better, or it will be worse. So there should be some comparison of a certain quantity which should tell you that which fit is better. Yeah, so what should be that?
Accuracy and closeness to the real value.
Yeah, we can basically the magnitude of the error. So this might be okay. So let me just ask you, have you studied probability and stats? I guess yes.
Yes.
Yes, ma'am.
Yeah, so in stats you studied the various tests, those hypothesis test, R square. There was measures of the goodness of
Yes,
straight
ma'am.
Yes, ma'am.
test
Yes.
of interval,
मैम
interval of confidence.
पढ़े हैं मैम, भूल गए लेकिन.
Okay, but हमें उतना extensively use नहीं करना है इसको, but you will be again looking at these terms to compare different fits. So they are the parameters. And one thing more, so ये तो theory है, मैं explain कर रही थी आपको क्योंकि ये सब आपने already पढ़ा हुआ है. The basic is this, but today we'll learn it how to do it directly using a toolbox. So now
Excuse
you,
me, मैम.
yes,
मैम वहाँ पे मैम नेटवर्क की इश्यूज आ रहे हैं आपकी साइड से मैम.
okay, then let me just see again. अभी मुझे तो वैसे सही मेरे तरफ से सही दिखा रहा है. अभी तो नहीं आया, पहली बार आया था एक इंटरप्शन, अभी फिर से आया है क्या?
मैम बीच बीच में आ रहे हैं मैम. अभी भी क्लियर है वैसे, लेकिन मैम बीच बीच में आ रहे थे.
चलो ठीक है, if it comes again I'll change the connection, but
Okay.
right now, ठीक है.
Okay.
Okay, yeah, so yeah, what I was telling, so this was all theoretically. आपने इसका कोड बनाया होगा NA में, least square का, linear fit का और polynomial fit whatever. So there we used to do with the help of a program, and at one time we can just make program for one curve कि हमें straight line fit करना है तो उसी का formula से equation निकालेंगे और quadratic polynomial fit करना and so on. But today we'll learn how to do this in MATLAB using the toolbox directly. So this curve fitting will be done in seconds, in fraction of seconds with the toolbox. So because learning this using this toolbox is also a part of your course. So because coding, so now I suppose I expect that you should be already knowing that. Anyways, we'll be doing a lot of programming also, but this is a first lab. So I just want to make you familiar with some toolboxes. So we'll be using the curve fitting toolbox. So I'm using this window of MATLAB. So अभी अगर आप लोगों ने simultaneously इसको करना है, आप कर सकते हो. You just tell me how you want to execute it. Firstly I'll show you what to do, and then you can practice that and ask me the questions. And then I can see your screens also if you want to ask me anything. So there are commands also, and there are direct toolbox में आप जाके कर सकते हो. So in command window, what you will be writing here, let me just first clear this one. Are you able to see the MATLAB screen?
Yes, ma'am.
Yeah. So in command window, what I'll be doing, I'll be just writing this CF tool. So CF stands for this curve fitting. Tool is the command which you have to do for opening the curve fitting toolbox. Otherwise, you can go to this also. On the top of the screen, you are looking at this home, plots, apps. So if you go to apps, so you will see here various toolboxes. Curve fitting is the first one. So it really depends upon whether you are having this toolbox or not. That depends upon the time of installation, whether you installed this toolbox or not. Because कुछ तो by default वो install कर लेता है, कुछ हमें manually install करने पड़ते हैं. So if this toolbox is not with you, you can install it because it's freely available. But otherwise, if it is with you, then it is all fine. So आप apps में जाके भी खोल सकते हो और command window पे CF tool टाइप करके enter press करोगे, then also you can see this curve fitting toolbox. Yeah, so it's just taking some time. Okay, are you able to see this curve fitting tool?
No, ma'am.
नहीं दिख रहा. एक मिनट, मैं दोबारा से उसको स्टॉप शेयर न्यू शेयर करती हूँ. इसको ना ऐसे ही करना पड़ता है. कहाँ गया? Where? Yeah, here it is. Okay. Because it opens up a new window, so I have to share the new window. Now you are able to see that?
Yes, ma'am.
Okay. So here this is the data you have to, obviously आपको पास data होना चाहिए पहले curve fit करने के लिए. So यहाँ पे fit name whatever you can keep, because हम तो अभी एक सिर्फ example ही सीख रहे हैं. So whatever you give, whatever name you keep. अब x data, y data, z data. So basically अगर आपको 2-dimensional curve fit करना है, means you have just 2 dimension, space and time or whatever, x and y. So you will be just giving values for x and y. But अगर आपके पास 3D model है, उसकी 3 dimension है, so you will be giving values for z also. But so ये डेटा आएगा कहाँ से? सो व्हाट यू कैन डू, या तो आप डेटा डाउनलोड कर सकते हो फॉर सम प्रोसेस जिसके लिए आपको कर्व फिटिंग करके देखना है. Like I suggested you this COVID-19 data, you want to get it from somewhere, and but it's not easy to get the data directly from Google. You have to explore more and get that data exactly in that data format. It should be like the .txt file. So sometimes we need to do the conversions in order to import the data into MATLAB. So that part we can do depending upon जब हम करेंगे. But अभी के लिए what I'm doing, I'm using the default data files available with MATLAB library. So MATLAB में already कुछ data files available हैं, हम उनको use करके यहाँ पे सीख लेते हैं that how to do this curve fitting. And for that I again have to go back to my command window, because यहाँ पे सीधा data नहीं आएगा, आपको पहले data load करना पड़ेगा अपने workspace में. So we are back to the command window, and these folders you can see on this side. You see the workspace in the top, in the bottom left corner. This workspace is here. Yeah, so you can see ये workspace खाली है क्योंकि अभी हमने कोई कोड रन नहीं किया है. अगर हम जब कोई कोड रन करते हैं तो ये workspace में उसकी आउटपुट फाइल सेव हो जाती है, उसको हम सेव भी कर सकते हैं एज अ .mat फाइल. बट बिकॉज मैंने क्लियर ऑल कर दिया था तो जो भी इसका एग्जिस्टिंग डेटा था वो यहाँ से चला गया है. तो आपने पहले कोई कोड रन किया है सो उसका डेटा यहाँ पे पड़ा होगा, आप उस डेटा को भी यूज कर सकते हो कर्व फिटिंग के लिए. बट अदरवाइज यू कैन load the data files which are already present in MATLAB library. Like here I'm giving you an example of this command load. So load is a command to load a data file. और आप import data भी कर सकते हो वैसे अगर आपने कहीं डेटा फाइल सेव किया हुआ है अपने सिस्टम पे. सो यहाँ पे ऑप्शन होता है import data का in workspace. Let me see where it is. या workspace पे नहीं होता है but somewhere you will find it. Home, yeah, on home if you go, import data is here in the top, but otherwise in command window you just write load and then the file name. So वो file name मेरे पास है census. ये आपको ऐसे याद रखने की जरूरत नहीं है. These are just examples. You will find plenty of other data files also. But curve fitting समझने के लिए I'm just taken one example. It's already with MATLAB. I have not created this one. This is already there. So load census when you will press enter. Now you look at the workspace and you see you get two variables here. Are you able to see them?
Can we import CSV files too?
Yes, you can.
Okay.
Yeah, so here you see this is C date. This is one data and it's a vector, sorry. 21 cross 1 double, you mean, so that's a matrix of one column. So basically if you click on it, you can see the contents of it. That, let me show you the values. This is like one column. So all these are the some C date, means ये years हैं. You can see 1790, 1800. So ये कोई population census का data है जो default इसमें fit है. तो ये years इसमें है हमारे data में in this file. और ये POP जो है that's population. So इसका कुछ unit होगा. So it's 3.9, 5.3. It should be something million, billion, whatever it is. Right now we are just interested in the values of it. So हमने इसको जब workspace में load कर दिया है, now you go back to your curve fitting toolbox because now it is available in the workspace. So we'll be able to call it there in the curve fitting toolbox. Earlier we were not able to do that because there was no data present in the workspace. So I'm going back to the curve fitting tool now. And here you will see X data. So it's showing you option. Earlier it was not showing any options because no data was available. So X axis पे आपको क्या रखना है? So that's the date, means whatever it is years. और Y axis पे हमें रखना है उसका population value and nothing. मैंने अभी कुछ press नहीं किया है. It has by default fitted a curve. So अभी सिर्फ मैंने X data, Y data उसको बताया है. C date, Y date, what it is. It has fitted. और ये कौन सा curve fit हुआ है? You look in the topmost middle here. It's a polynomial. You can see in the middle, it's a polynomial of degree 1. So basically that's a straight line, and by default it has given me this fitting. Now you want to see that various characteristics of this fit, because the way I explained you there in whiteboard, that actually the equation looks like y equals to ax plus b. Let me just simultaneously open that, but I don't know we will be able to do it. In fact, okay, let it be like this. You are able to see here results on the left hand side. It's a linear model, polynomial 1, means polynomial of degree 1. So this is p1x plus p2. That's the fitted equation. So these are the coefficients p1 and p2 with 95% confidence bound. So, okay, can anybody explain me the meaning of this? 95% confidence bounds. That's statistics.
Ma'am, 95% may be probability of coming a result.
Yeah, means it's 95% of the test cases. Hello?
Ma'am,
Hello, can you repeat? Saurav, I could not hear you.
I said that it is maybe 95% probability of getting the results.
या वैसे जब भी आप प्रोबेबिलिटी बताते हो तो हमेशा उसको 0.95 बोलना होता है, परसेंट में हम प्रोबेबिलिटी नहीं बताते, बट इट्स एसेंशियली द सेम मीनिंग. मींस अगर आप इस पे 100 टाइम्स 100 डेटा के साथ इसको चेक करोगे तो इट्स 0.95 प्रोबेबिलिटी और 95% चांस है कि वो आपका P1 जो है इसी इंटरवल में ही लाई करेगा विद दिस डेटा. सॉरी, डेटा नहीं बदलना है. With this data, so it's 95% times or 0.95 is the probability such that this P1 value lies between this interval 1.045 to 1.387, and similarly for P2 you have a range. And what is this goodness of fit? So goodness of fit देखने के लिए कुछ measures हैं, statistical measures हैं ये सब. So I'm not going into details of this, probably you already have the idea. SSE stands for sum of squared errors. So जो हम कंप्यूट कर रहे थे मेथड ऑफ लीस्ट स्क्वायर में, मिनिमाइज करने से पहले तो आपको एरर्स निकालने हैं इंडिविजुअली, उनको स्क्वायर करना है और फिर उनका सम करना है. सो दिस इज अ सम ऑफ स्क्वायर्ड एरर्स व्हिच आई कैन सी इज क्वाइट ह्यूज. इट्स 9757. दैट्स अ वेरी लार्ज एरर. R square and adjusted R square. R square, this is actually computed from the variance. Yeah, you know, you are familiar with these terms? R square value?
Yes, ma'am.
Yeah, हमें ज़्यादा
Yes,
use
ma'am.
नहीं करना है, but here these are basically to tell you to compare the fits की R square value represent करता है कि हमारा fit कितना अच्छा है. Like 0.921 means it's a good fit because it's like 92%. You can say it's 92% close to the real data. So basically it's because it's also computing the differences between the data and the average taken from the data points. So ये R square है. There's a little difference between SSE. वो डेटा वैल्यूज के एरर्स होते हैं, ये मीन के साथ जैसे वेरिएंस निकालते हैं वहां से आता है. एंड देन दिस इज रूट मीन स्क्वायर एरर. सो रूट मीन स्क्वायर एरर ऑल्सो यू नो द सम ऑफ स्क्वायर्ड एरर्स. सम करने के बाद हम मीन लेते हैं, डिवाइड करते हैं बाय n, द नंबर ऑफ डेटा पॉइंट्स, एंड देन वी टेक द रूट, स्क्वायर रूट ऑफ दैट. So that's root mean square error, and that also I can see is quite high. 22.66 is a very big error number, root mean square error. So that means this is not a very good fit. But so this is how this toolbox is working. It will give you the values of every fit, the goodness of it, and all these things here. So you can compare and decide which is going to be suitable for you. Right? So here, from here you can change the options. Again, you go back to this option. अब डेटा हम यही रखेंगे, but we'll just fit different curves to this. So what you can do if you want to save the output, आप इसको as save as figure कर सकते हो. ये as a figure file export हो जाएगा. Print to figure means ये जो fitting curve मुझे दिखा रहा है population versus date, means this is the real data. जो black dots हैं वो real data points हैं, और जो blue curve है that's a straight line जो हमारी approximate curve fit है. When you will click on this file and you will print to figure. Are you able to see this? Okay, so ये print कर देगा उसको figure file, MATLAB figure file save करेगा उसको, आप save as PNG और वो सब कर सकते हो. So that's easy to do that. And otherwise, if you want to change the different polynomial fitting, so that also you can do from here. This is polynomial of degree 1. So I'm changing the degree now. So let's fit a 2-degree polynomial. Are you able to follow these? Yeah. Any doubts so far?
No, ma'am.
Okay, so now I've changed the curve fitting. Earlier it was straight line fit, now I fitted a quadratic polynomial. I've changed the degree from here, degree 2. You see, that's what I was telling you. Earlier we were making programs for the same thing using the method of least square. हम linear fitting के लिए अलग program लिखेंगे, quadratic fitting का अलग program लिखेंगे. But here you can see directly with the help of just changing these values, you are getting the fits directly in front of you, and even a much detailed analysis you are getting to look at. So now you again look at this results section. So this results section is again showing you all those things. So this time it's P1 x square plus P2 x plus P3. So that's a quadratic polynomial fitted. Again, the coefficients have been given with 95% confidence bound. So these are the values of P1, P2, P3. Because see, in the beginning I told you this is what the engineering people are trying to do. They have the data, they fit a curve, and then they get the curve. So ये curve यहाँ से क्या आ जाएगा, ये वाला. So they get the mathematical model for their data. So that's a way to get the mathematical equation. So they have this quadratic curve from here. And goodness of fit, if you see, so this is not still very good because the error, sum of squared error is okay, still 159, not a very small number, and root mean square error is also 2.972. But if you look at the R square value, so it's quite good. It's like 99% precision is there between the real data and the fitted curve. So that's in comparison with the first curve, जो इससे पहले हमने linear polynomial plot किया था, fit किया था, उसके comparison में ये better है, right? So इसको भी आप as a output इस figure को print कर सकते हो, save कर सकते हो. And now let's just do the experiment. Degree 3 करके देखते हैं. So if you will be doing degree 3, so this time again I get a fit, and in the results section if you look at, these are the values. So ये sum of squared errors इतना भी improve नहीं हुआ है. पहले ये 151 था, अब ये 149.8 है. R square values, adjusted R square
Excuse me,
values.
ma'am.
Yes, yes.
मैम वहाँ पे रिजल्ट सेक्शन में इक्वेशन इज बैडली कंडीशन लिखा है, इसका क्या मीनिंग हुआ?
हाँ, I'm coming to that. तो ये मैं बता रही थी, आपके पास ये क्यूबिक इक्वेशन के वैल्यूज आ गए और इनका बाकी फैक्टर्स कंपेरेबल ही हैं जो क्वाड्रेटिक में थे, तो इतना ज्यादा मतलब एक्यूरेसी में फर्क नहीं पड़ा है. ओके, सो आपने इंटरपोलेशन भी पढ़ा होगा न्यूमेरिकल एनालिसिस में. इंटरपोलेशन में भी ऐसे ही होता है कि जितने बेटर फिटिंग हम चाहते हैं, सो देयर हैज टू बी अ एप्रोप्रिएट नंबर ऑफ पॉइंट्स. लाइक 5 points के लिए we fit a biquadratic curve, 3 points के लिए we fit a quadratic curve, and so on. So which one is better? Okay, let's not talk about here interpolation. I'll go back to the interpolation later. Let's first discuss this one because वो connection नहीं बनेगा. Okay, let me just answer this. Equation is badly conditioned. Remove repeated data points or try centering and scaling. तो एक center and scale पहले try करते हैं. Yeah. And now you see the fit is there, but वो badly conditioned वाला जो error है वो चला गया है. और center and scale अगर हम नहीं करते हैं, so you see this thing you have to experiment. I'll share the recording of the lecture and then you can go back to this recording and do that again if you're not able to follow up that quickly. तो ये सेंटर एंड स्केल है यहाँ पे पॉलिनोमियल फिटिंग के नीचे. अगर हम इस ऑप्शन को यस कर रहे हैं, सो यू आर सीइंग वो बैड फिटिंग वाला, बैड कंडीशन वाला एरर चला गया और कोएफिशिएंट्स की वैल्यू भी चेंज हो गई है, बट स्टिल द गुडनेस ऑफ इट, वो सब वैल्यूज अभी भी सेम ही है. So this center and scaling is a technique basically used in statistics to improve or you to take care of the badly conditioned system. So you might have studied this ill conditioned system. ये भी हमने numerical analysis में पढ़ा था. Ill conditioned system हम किनको बोलते हैं?
Where if we change any value, it affects the system badly.
Yeah.
In the systems in which we change some value, if the value change affects the system very badly, is the ill-conditioned system.
Yeah. So basically, it's like, जैसे मैं again I'll just give you a linear equation system of example. उससे आपको याद आ जाएगा वहाँ पे कैसे पढ़ते थे. Say you have 2x plus 3y is 5. I'm writing is hypothetically. X minus 2y is say 4. Say whatever your system is. So you solve this. I'm not going to solve it. So you solve this and get an answer, right? So suppose whatever answer you get, x1, x2, or sorry, some x5. Now if I change this 3 to say 2.99, one of the parameters, one of the values in my system I changed very minutely. From 3, I have just changed it to 2.99. So what is going to be the effect on the output? So that's the checking the stability of the problem basically, or the ill-conditioned or well-conditionedness of the system. That if a small change in input implies or it gives rise to a small change in output, then our system is well-conditioned. But otherwise, if a small change in input gives rise to a huge change in output, then those systems we call ill-conditioned. You might have studied the system of equations is said to be ill-conditioned. फिर हम उसका condition number निकालते हैं. Condition number is too high, so we say ये ill-conditioned system है. अब ये systems problematic क्यों होते हैं? Because you see, अब आपको ये जो information आ रही है ये कहीं real data से आ रही है कि ये coefficient 2 होना चाहिए. But your real measurements are not always exact. हो सकता है जिसने इसको measure किया हो उसकी exact value 1.99 हो, but आपने approximately 2 समझ के उसको solve कर दिया और एक answer दे दिया. So if the answer is quite different for 1.99 and 2, so that means your answer may be entirely wrong. So that's why जो ill-conditioned system होते हैं, they are not going to be good to work with because they do not have any scope of the minor errors in the input data. और वो minor error input data में हमेशा present होते हैं क्योंकि वो real life से जहाँ से भी हमने वो values उठाए हैं. That's why we always want to get rid of this ill conditioning in the system. So same is here. When you are looking at this curve fitting, which we did, it's written over here that equation is badly conditioned. So ये equation इस equation की बात कर रहे हैं जो इन्होंने fit करके बताया cubic polynomial. fx is p1 x cube plus p2 x square plus p3 x plus p4. Badly conditioned means यही है कि आपका जो data है अगर उसमें एक वैल्यू भी थोड़ी सी भी चेंज हो गई, लाइक वट एवर इज योर डेटा से, ये आपका जो पॉपुलेशन डेटा था से किसी एक डेटा पॉइंट पे पॉपुलेशन 243 है, बट इंस्टेड ऑफ 243 से इट इज 244, इट्स अ वेरी स्मॉल चेंज, तो आपका सॉल्यूशन इंटायरली बदल जाएगा. सो दैट्स द मीनिंग ऑफ दिस बीइंग बैडली कंडीशन कि a minor change in your input data is going to produce a big change in the output. Therefore we want to get rid of this. So ये badly conditioned वाले को हम कभी reliable नहीं मानते, इसलिए will better either stick to the polynomial of degree 2 because उसमें भी comparable r square और root mean square आ रहे थे, but it was not badly conditioned, at least it was reliable. But अगर आप 3 में जाते हो तो badly conditioned answer आता है. So they are suggesting to use a technique of centering and scaling. So उसमें क्या है, सिर्फ कैलकुलेशन करने का तरीका बदला जाता है सेंटरिंग एंड स्केलिंग में, बिकॉज सिस्टम आप चेंज नहीं कर सकते हो, आप डाटा को मैनिपुलेट नहीं कर सकते हो, बट समथिंग इज डन सो दैट द एरर इज मिनिमाइज्ड. मींस आपका जो सिस्टम है वो इल कंडीशन से वेल कंडीशन में कन्वर्ट हो जाए. सो यू कैन यूज दिस टेक्निक. मींस बेसिकली हमें कुछ नहीं करना है, हमें अगर ये टूल बॉक्स यूज करना है, सो वी जस्ट नीड टू press this button center and scale. So what's the theory behind it? I really right now cannot go into the details of that, but if you want to study, you can study. So it's all statistics based. Okay, so this is for the situation for a 3-degree cubic polynomial. You want to try it for even higher degree, you keep on doing that. So for a 4-degree polynomial, the error started increasing. Okay, if you look at the root mean square error, you take a note of it. It is 3.02 this time for a 4-degree polynomial. Why I'm increasing the degree of the polynomial? Because it's a general intuition that the higher degree polynomial may probably fit it better. So we are just doing an experimentation. We do not know which one is going to fit better. So we are trying with the variation of the degree. So 4 degree से इसका जो root mean square error है 3.02 आ रहा है, but 3 पे या फिर 2 पे जो हमने देखा था that was 2.9. So there is a difference. Rather you can say कि 4 degree polynomial की fitting पे आपका root mean square error जो है वो बढ़ गया है, it's increasing. Sum of squared errors जो है आपका कम हुआ है, but that's very minutely less, but root mean square error is increasing, sorry. And then you can try even with higher degrees. So it remains comparable. So जब आपका error comparable है, ज़्यादा high degree पे आपको जाने की ज़रूरत नहीं है, because the system becomes more and more complex to solve. So better at least if for this experimentation, इस data के लिए अगर हम कुछ कहेंगे, so I'll go with the cubic polynomial, and that with the improvised center and scaling technique. Otherwise, it's also good. A quadratic polynomial fit was also working equally good there. So rest you can try and experiment which is a good fit. So out of the polynomials, these options available here, I selected this quadratic polynomial to be the good fit. Because see, whenever you are doing these kind of things in modeling, nobody is going to ask you, give me the best fit. Nobody has an answer to it, which is the best fit. क्योंकि कई बार क्या होता है, एक पैरामीटर को इम्प्रूव करने के लिए लाइक आप रूट मीन स्क्वायर एरर पे फोकस कर रहे हो, बट आपके बाकी प्रॉब्लम्स जो हैं, बाकी पैरामीटर्स गड़बड़ा जाएंगे. So it's you have to make a good combination, an optimal combination, so that all things remain in place. You cannot just focus on one statistical parameter. That is why multiple statistical parameters are taught to you, mean, variance, standard deviation and all those things, और उन्हीं को यूज करके ये सब निकालते हैं, R square and root mean square error. So आपको बहुत ज़्यादा भी इसके ऑप्टिमाइजेशन में नहीं पड़ना है कि हमें बिल्कुल बेस्ट फिट चाहिए, but you need to be somewhere satisfied with it. So this was one kind of fitting, polynomial fitting, right? Polynomial fitting is like, you know, the polynomial structure looks like. It's a linear polynomial, cubic, quadratic. We fitted all kinds and got one answer. So far, if you have any doubts, so please ask. Or should I take a pause here? You all want to do in this your respective MATLAB, so you can do, take 5 minutes and then come back with the doubts. Because see, this is, we need to execute it in this way. We need to figure out which way it works better. Yeah, anyone has anything to say?
Excuse me, ma'am.
Yes.
Ma'am, basically, ma'am, some of concepts have been forgotten by me, ma'am. So, ma'am, is there any issues with that?
नहीं, ऐसा नहीं है. क्या मतलब, क्या भूल गया बताओ?
मतलब मैम जैसे हमें इंटरपोलेशन वगैरह भूल चुकी है मैम न्यूमेरिकल एनालिसिस की.
वो देखो, ऐसे तो आप भूल जाते हो, बट पढ़ के याद आ जाता है.
यस मैम.
हाँ, तो ऐसे ऐसा हमें डायरेक्टली इंटरपोलेशन इस कोर्स में कहीं नहीं यूज करना है, बट ये तो जैसे जैसे जो टर्म आती जा रही है, सो आई एम जस्ट ट्राइंग टू कनेक्ट विद व्हाट यू हैव ऑलरेडी डन. बिकॉज अभी हम एटलीस्ट ये कर्व फिटिंग टूल बॉक्स में हम करेंगे इंटरपोलेशन भी, बट आई विल रिमाइंड यू व्हाट इट वाज. बट एग्जैक्टली हमें उसको याद रखने की जरूरत नहीं है, जस्ट हमें अंडरस्टैंडिंग चाहिए उसका बेसिक. Okay, so all of you have MATLAB open with you?
Yes, ma'am.
Yeah, so you just take 5 minutes and do this, whatever I have done so far. So I can repeat the steps. You go to command window, load the data file named census, CENSUS. And from there you open the CF toolbox and load X and Y variable and do this experimentation. right? So I've just been online. So you take 5 minutes and come up with your doubts. We need to continue this further. अभी हमने polynomial fit किया है. अभी ये यहाँ पे और बहुत सारे तरह की fittings हैं which we can try and experiment. But I'm just taking a pause and you try this. In between, I can take your doubts. Okay, so I have enabled the option of screen sharing. So I don't know, simultaneously though I won't be able to see, but one by one, if you want to share your screens, what you are doing, or if you are facing any difficulty, so you can ask.
Excuse me,
Yes.
डेटा कहाँ से यूज करना है, डेटा सेट या कोई
ये
भी
ये
एक
मैटलैब
से
में
रैंडम यूज कर सकते हैं?
मैटलैब की लाइब्रेरी में डेटा है, सेंसस, और भी फाइल्स हैं. आई विल गिव यू अदर एग्जांपल्स आल्सो. और भी फाइल्स हैं. अब वो एग्जैक्टली कहाँ सेव्ड होती हैं वो ढूंढना पड़ेगा. डॉक्यूमेंट्स में, लाइब्रेरी में होती हैं डेटा फाइल्स. बट अभी जो मैंने एग्जांपल बताया, आप इसी से एक्सपेरिमेंट कर लो. सेंसस, इट्स CENSUS, लोड लिख के आपको सेंसस प्रेस करना, टाइप करना है. अदरवाइज आप अपने पास कोई एग्जिस्टिंग डेटा फाइल है उसको इंपोर्ट कर सकते हो एंड ट्राई कर सकते हो इंपोर्ट डेटा में क्या क्या प्रॉब्लम आती है.
Excuse me, ma'am.
Yes.
Ma'am, what are the weights in the curve tool?
Where it is?
There's a drop down for weights as well in XYZ. What is the meaning of weights?
Can you show me your screen? Can you
Yeah,
share?
ma'am.
Yeah.
Yes, ma'am. I'll do it. Yeah, ma'am. Is it shared?
It's shared, but still loading. Yeah, I can see that. Yeah.
Yeah, this one, ma'am.
Weights. Just
Yes.
if you look at the drop down, is it showing anything?
Ma'am, these options are on.
But it's the same thing we have used as X data, Y data. Right now, I am not able to give answer because I have not used it anywhere. मैंने कभी use नहीं किया अभी weights का option, but
Okay.
basically it's showing the same data, so I don't think so. It
Okay.
will be any usage right now. इसको select
Okay,
करके
ma'am.
देखो कोई फर्क नहीं पड़ेगा. आप कुछ भी ले लो. I don't think
Yes,
so.
ma'am. ऐसा कोई फर्क तो नहीं पड़ा वैसे.
हाँ.
The values are changing a little, I guess.
Hmm?
The values are changing.
Values
The goodness of fit.
goodness
That
is changing.
yeah.
Okay, I'll read about it. मैंने इसको यूज नहीं किया कभी. अभी मुझे नहीं पता ये इसका क्या पर्पस होगा वेट्स डालने का. Okay,
Okay,
I'll
ma'am.
answer that when I get an answer for it.
Sure.
Is your hello?
Hello, yes.
क्या उसी बेस को डिग्री के नीचे रोबस्ट लिखा हुआ है, इसका यूज क्या होता है वैसे?
Yeah, robust is like, it's something like, say आप ऐसे तो जैसे एक आर स्क्वायर वैल्यू है, एक एडजस्टेड आर स्क्वायर वैल्यू है. इफ यू हैव आई विल जस्ट गिव यू एन एनालॉजी. जैसे हम प्रिडिक्टर करेक्टर टेक्निक्स यूज करते हैं एनए में, कि एक फॉर्मूला है हमारा वैल्यू को प्रिडिक्ट करने का और दूसरा उसको इम्प्रोवाइज करने के लिए है. सो इट्स काइंड ऑफ एन इम्प्रोवाइजेशन ओवर समथिंग. सो पहले आप अपना एक प्रोग्राम बनाते हो और फिर उसको ऑप्टिमाइज करते हो टू गेट रिड ऑफ द ऑल दोज थिंग्स. सो robustness, this routine is there some to take care of these things. So it will depend on what technique is running behind, what routine subroutine is running behind, and how this robustness is making it that. So it's means essentially you can understand it's just going to make the things better. Otherwise means as such it's not going to change anything drastically. You can let me just go to this and show you here. So if you make this robust, so these are robusting techniques. So these are also in statistics you study. Uh, because as such, I have also not used those techniques, but I have just some idea that these are some techniques to make or improvise the performance of the system. So that's the meaning of this. And there are few techniques if you want to apply. So you can just go and experiment whether it's changing anything or not. Yeah, so it's changing the root mean square error. It's making it this. See, if we'll go into details right now of these things, so basically it's like studying statistics at this point, but it has something to do with that. Okay, if you want to study in detail, you can go and search. But here you can try it. Like I tried, so it increased our, sorry, it improvised our fit. It changed the root mean square error to a good value, means it decreased the root mean square error value. So that's a good technique. This robust option you can use. And similarly, there are other fit options also. Oh yeah, so it's just showing you it's what technique it's using. It's least square method it is using, which I explained you in the beginning.
Okay.
Yeah. Okay, so is it done?
Yes, ma'am.
Have all of you tested your this polynomial option?
Yes, ma'am.
Yeah, so we can just have for the same example, you can now change the type of the fit. So instead of polynomial, if you want to fit, say, exponential curve, exponential, you want to see whether it fits the exponential. So you look at this left hand side, I have chosen exponential, and from here you can change the number of terms. So the number of terms is 1, means it will be of this kind. Fx is a e raised to power bx, because that's how a general exponential expression looks like. if you remember, if I again, what happened? Yeah. So if I again remind you that this kind of questions also you used to do in least squares, that okay, fit a curve of this kind. So this kind of question was given to you. So how do we used to do this? We used to take the logs, and then so it will give you basically this constant will go, and taking the logs of this will give you a straight line. So that's not going to do that, just reminding you, and that straight line will be the linear function, and then you minimize the errors. So it's basically the same thing what you are doing here when you are trying to fit an exponential curve with one term. So it's the same thing, a e raised to power bx. So it's giving you the value of a and b, and these are the obviously goodness of it and all those things again. Center and scale, if you want to apply, so this changes the values to bit. It normalize with respect to mean and the standard coefficients. It changes the value, but still you get a better fit. Number of terms, you want to see whether it gives you a better fit by increasing the number of terms or not. So you can try that. So this time I can see I'm getting a root mean square error of 5.291, while when I was using the number of terms was just 1, then I was getting it's 9.985. So with number of terms 2 used, it's giving me a better answer. And this is how the model looks like when you take the number of terms 2. It's written over here also. A e raised to power bx plus c e raised to power dx, and same is here. The calculation is shown here, and the values of a, b, c, and d are also shown here. So, and it's not a, you can say, fixed thing. It's not always going to work that excuse me, it's not always going to be that you increase the number of terms that you're getting a better fit. It's not always going to be that. It really depends upon your data to data. So you just have to see and do the experimentation. And one thing more, here in the curve fitting toolbox, you're getting a lot of options, but if you want to all do these things with the MATLAB code, you can write a script for the curve fit also by using the commands. So then there are certain commands which you can just explore by typing help. If you go to the command window, you'll just type help curve fit. So that will give you a list of commands, or you can even learn that online in MathWorks. But otherwise, essentially, there is no use to do that, because all more than a number of options you are all getting what in this toolbox. So this was about the exponential option. You want to then fit a Fourier curve. You know that how a Fourier curves look like. It has the terms from cosine and the sine terms. So, and there is an amplitude to that. So if you want to fit a Fourier curve, so this is the root mean square error you are getting. So here also you can increase the number of terms, because cos x sin x, all of you have studied this Fourier series. Fourier series पढ़ा है ना सबने, तो उसकी सीरीज एक्सपेंशन हमारे पास क्या होती है, हम किसी भी फंक्शन को एज अ फोरियर सीरीज रिप्रेजेंट कर सकते हैं, मींस एज अ सम ऑफ साइंस एंड कोसाइन टर्म्स प्लस द कांस्टेंट टर्म इज देयर. It depends upon the data that if constant term needs to be included, and then if you increase the number of terms, वो उसका amplitude बढ़ा देता है 2x 2x. You further increase the number of terms, it becomes 3x 3x. Amplitudes are also included, but you see the model is becoming increasingly complex if you increase the number of terms to that, and your other parameters are also changing. So you do not have to compromise, or you just do not have to always focus on getting the root mean square as small as possible, because you also see on the other side your model complexity is also decreasing. Okay, so here is a question. Why we are doing this, means if it comes to your mind, why we are interested in looking at this model. डेटा है वो बदल रहा है, ठीक है बदल रहा है, हमें क्यों जानना है ये मॉडल, व्हाई वी आर इंटरेस्टेड इन लुकिंग एट द मैथमेटिकल एक्सप्रेशन ऑफ इट. Anybody can answer it, because that will help us to understand something about it.
To predict.
One by one, yes. Aniket.
Like we got a linear expression or any mathematical expression, so we can find the values on which our data set do not have that particular values. It is easy for us to predict
Yeah.
the ones
So
which has already done.
yeah, so that's actually a right answer basically, because the mathematical models are most of the times used for prediction. So there was one thing which was interpolation, other thing is extrapolation. इंटरपोलेशन होता है कि हमें गिवन डेटा के इन बिटवीन ही डेटा पॉइंट्स की वैल्यूज को प्रिडिक्ट करना है. लाइक इफ यू फोकस ऑन द वैल्यूज इन बिटवीन, ये जो रियल डेटा है ये ब्लैक वाले डॉट्स हैं और ब्लू वाली कर्व आपकी प्रिडिक्टेड अप्रोक्सीमेट कर्व है. तो जहां पे रियल वैल्यू नहीं थी वहां पे पॉपुलेशन क्या होगा उस टाइम पे, दैट्स द इंटरपोलेशन, दैट्स द आंसर कमिंग फ्रॉम इंटरपोलेशन. So that answer you can give by just substituting that particular value of x. Suppose you know the population at 1880, you know the population in 1890, but you do not know the population in 1885. So what was happening exactly in the middle of it? So that answer you can get by substituting x equal to 1885 in this model, and that way you will get the accurate value or the predicted value, I should say. So that's one thing. जहाँ पे वैल्यू नहीं पता है वहां पे पता करने के लिए थ्रू इंटरपोलेशन. एंड अदर इज एक्स्ट्रापोलेशन. एक्स्ट्रापोलेशन मींस आपका जो ये पूरा डेटा है 2000 ईयर तक है. द लास्ट ईयर फॉर विच डेटा हैज बीन यूज्ड इज 2000. सो आप इसी कर्व को यूज करके 2020 में या 2040 में प्रिडिक्शन करना चाहते हो तो यू कैन यूज दैट, बिकॉज वहां पे आपके पास रियल डेटा नहीं होगा बिकॉज दैट्स अ फ्यूचर वैल्यू, but you do have your curve. You can extrapolate this curve in future and then get the value, approximate value, that if this trend continues then what is that future value which I am going to get. It's very much useful over there. That's the actual usage of curve fitting. We want to fit a curve because we need to have a model which can predict our future values. But a lot many things others are also involved. You cannot just extrapolate to infinity. अब बहुत आगे नहीं जा सकते. You have to be very much close to the data because it really depends upon is that trend you are looking at is same. It's a monotonous trend. It's a continuously increasing curve, or it has jumps in between. Like this is a population, so I can see वो monotonically increasing है. So obvious है कि future में भी it's still going to keep on increasing up to certain extent. So that depends on model to model how valid is that extrapolation, but that's the usage I wanted to ask. You should know this. So that's why I was telling you that we do not want to make the model much complicated कि हम accuracy इतनी बढ़ाने के लिए कि ठीक है रूट मीन स्क्वायर एरर कम कर दो, but उससे हमारे मॉडल की complexity भी बढ़ रही है. So we have to make an optimal combination of that. That depends upon how much efficient means it really depends upon what you want from the model. जब हमें बहुत highly accurate result चाहिए होते हैं then it's okay, let the model be complex. But sometimes we are also working on that our computational cost should also be less. The resources, okay, इस scale पे आपको computational efficiency या computational cost का sense नहीं समझ में आएगा because this program is just running in fraction of seconds. It's giving you the output, so it really doesn't matter howsoever complex answer you're getting because it's coming in fraction of seconds. You can see that. Okay, but you understand the meaning of computational complexity? All of you are familiar with this term?
Yes.
Yeah, so that's the basic thing you have to take care of with these kind of things that do not unnecessarily make the model very much complex. And same is here, you can do that experiment and just keep on getting the answer. So that was with Fourier. Similarly, you have interpolant. So interpolation, this is something which I was talking about. What interpolation just does, it just connects them to the degree, like it works piecewise. As you can see here, it's not a general curve equation. You can get the general curve equation, the interpolant polynomial, but this is done piecewise over here. If I'll explain this to you, just a minute. So if I'll just explain what interpolation means, interpolation is something I was just using the word that this is the data point, this is the data point. So if you just have 2 points, so we know the straight line, sorry, The straight line is going to fit these two data points. And if you have say 3 points, so ये तो collinear है, but suppose you have some other combination, so you want to fit a other polynomial, you want to fit a sine curve, you want to fit a quadratic degree polynomial or whatever. So interpolation basically is used for this technique कि जिन points पे values नहीं पता है, in the middle there you want to determine it. So linear interpolation means अगर ये data points हैं आपके पास, so इनमें ये straight line combinations use होंगे. It will use 2 data points at once and just connects with a straight line, because linear interpolation is a straight line. Straight line, straight line and straight line. वो जब data points बहुत close होते हैं, so it may not appear as a straight line, but actually what linear interpolation is doing, connecting with the straight lines. Quadratic interpolation will at a time consider 3 points, fit a quadratic polynomial, and then use another 3 points, the next 3 points fit another quadratic polynomial, and so on. So that's the meaning of this interpolation here in the curve fitting toolbox. Wait a minute. Let me just go back to this curve fitting toolbox. Yeah, so ये interpolant का कौन सा degree आपको use करना है? Linear, cubic, and some other is there. I do not have any idea about it. These are some different techniques of interpolation, right? So whichever you can use. And it does not calculate the root mean square error, because ये curve जो होती है आपकी data points में से ही pass होके जाती है, because it actually connects point to point. It does not have any difference from the, there is no difference between the actual value and the predicted value, क्योंकि वो connect ही dot को dot के साथ कर रहा है, so these terms become insignificant. यहाँ पे error ही नहीं होता है, sum of squared error is 0. Or R square value is 1, because no 100%, like it's matching with the real curve, real data 100%, क्योंकि आपके real data पे तो exactly वो point के साथ match है, बीच में obviously हमारे पास real data नहीं है, वहाँ पे जो भी value दे रहा है that's acceptable. और root mean square error भी not defined है यहाँ पे, because we really cannot do that, क्योंकि error ही नहीं है यहाँ पे. So therefore these terms will not be defined if you use the option of interpolation like that. But these are not very much useful, because they just connect dot to dot, and they can rarely be used for extrapolation, because obviously this is just for the interpolation, so cannot be used for the extrapolation or prediction. Then you have a linear fitting, so they are just giving you a different kind of formula. So it's a times sine x minus pi plus b x minus 10 square. You can customize it over here. There's an editing option here. Yeah, you can see this edit, so you can do this editing. So x minus 10 is basically around what point, it's like the Taylor series expansion about what point you want to get the terms towards. So you can just experiment by putting different values and identifying the coefficients here. और सबसे पहले यहाँ पे एक option था top पे, custom equation. Custom equation में भी like यहाँ पे ये typed है custom equation, a exponential minus bx plus c, इसको भी आप change कर सकते हो. आप अपनी ही कोई curve की fitting कराना चाहते हो, suppose you want to fit a entirely new model जो यहाँ पे नहीं है, right, which is not available in these options, so you can type that here. You know the format, वो a b जो c है वो आपके coefficients की notation है, और exp is exponential function and x is your unknown, obviously y और x वो ही रहेंगे. So you can change the editing here and then do the experimentation कि वो fit कैसे हो रहा है. So वो custom equation में you can do that. And similarly we have other options. Polynomial हमने देख लिया. You have power series, so power law. Basically this is not power series, this is power law. So power law is something let me again go back to this. Power law is basically any law like this. Say y equals to x square. This is a power law, power relation, because y is varying corresponding to some power of x, right? Like this is linear, this is power is 1, 2x1, this is x square. This is different than a polynomial. See, this is a quadratic polynomial, all of us can understand, but if I write it like this, x raised to power half, then I know that this cannot be called as polynomial, because polynomials have the strictly positive integers as the powers. We cannot have the fraction or the rational powers, and we really cannot have the even the negative powers. But आपका in general अगर आप ऐसे लिखते हो x raised to power b, so this b can have any real value, right? It can have negative values also. So this is a general form of a power law or a power relationship between y and x. तो इस तरह की आपको curve fit करनी है, so that also is available there. So that's what is being done here. We have also done examples like this there also. In method of least square use हो रहा है इन सबके पीछे. So there also you can increase the number of terms from 1 to 2. So like in number of terms 1, there was no constant term, but when the number of terms you made 2, so a constant term got included. But you can see the root mean square error is now 9.509 and it was 9.255. So the number of terms 1 पे error was less, so compared to that it is better. But obviously हमें polynomial fitting में इससे better fitting मिला था power law से, क्योंकि वहाँ पे हमारा root mean square 1 point something पे भी पहुँच गया था. So obviously we will not be using this as a one of the option to fit this curve. And then you can have the other options from here. Let's see. A rational function, it's just a polynomial divided by another polynomial. That's the meaning of a rational function. So numerator में आपको constant रखना है तो degree 0, और denominator में obviously numerator की degree 0 means it looks like this. Fx is p1, a constant by some linear polynomial. So you can choose different combinations of the numerator and denominator degree from here and see which one is fitting your data. So ये rational function अगर आपको fit करना है तो. Smoothing spline is also kind of fitted curve. It is also a piecewise polynomial. It's just like you have a Lagrange interpolation जब हम study करते हैं. So that's something which I told you. Linearly आप उसको connect करते हो. और ये smoothing spline is also one kind of interpolating polynomial. यहाँ पे भी हम dot to dot ही connect करते हैं, but this accuracy is better. It has ये इसकी भी degree होती है. Cubic spline fit करना है आपको या of what degree. So sum of sines है. So these options are very rarely used. Like you can see here in the result section, fit computation did not converge. Fitting stopped because the number of iterations. So okay, again I can ask this question to you. Did not converge, what is the meaning of this did not converge? Yeah, computation did not converge. Can anybody answer that? Yes, any try? Okay, so it actually means whenever you are applying an iterative process, so you have to specify a tolerance limit, that when the error will be beyond within this limit, or it will be less than equal to certain number tolerance, then you stop. Otherwise you define the number of iteration, fixed number of iteration. So it for iterative procedures there has to be some stopping criteria. So sometimes our program stops because it's not able to satisfy the stopping criteria. It goes into an infinite loop. You have done these kind of examples in numerical analysis, that if your stopping criteria is not properly defined, so your program or your algorithm is not good enough to solve that particular problem, so then it will not give you an answer. You have to manually terminate it by you have to terminate it, or you have to fix the number of iterations, that this many iterations it has to run, otherwise it does not work. So that's something is happening here. If you are trying to fit this sum of sine, so that means this is not, we are not going to take that, and the errors values are also too high, so this is not going to work for this. So this example is to show you all the different possible kind of fittings which you can do using this curve fitting toolbox. There is much more to explore from here. Yeah, you can also see this. Here is a figure. From here, if you go to this fit and you see view, in this option file fit view, in view you, if you see residual plot, so these residuals are also plotted. Residual is the error basically. It's the difference between the data value and the predicted value according to your curve. So let me just change the curve, say let it be back to the polynomial of degree 2. So you can see the residuals are quite small just at these 2 points in between at 1940 and 1950. The errors are huge. Otherwise it's right, because residual is like error. It is not the square of the error, so it can be negative also. So you can have a residual plot. In some cases it is useful. You can have a contour plot. Contour plot abhi available nahi hoga because contour plot hamara 3D surfaces के लिए use होता है. It shows you the variation over a surface. तो आप surface fit भी कर सकते हो यहाँ से. Okay, I'll be just coming to that कि आप surface fit अगर करना चाहते हो, but this is all about the curve fitting toolbox. So if you have any questions, you can ask. Otherwise, I'll just give you one more example of surface fitting and then we'll sign off. Okay, so now I'm going back to this MATLAB command window. So here, let me just load another data file. So that's also one of the already available libraries. So it's a 3-dimensional data X, Y, Z. It has 3 vectors in its data set, because for a surface fit, I want to see this. So there again, going back to curve fitting tool. Now the previous session which you just did, you can save it, save session. Wherever you want to save it, say session 1. When you will be open this file again, it will again open as such in the curve fitting toolbox. On output of figures, if you want to save, I have told you already, you have to print to figure. And now I'm clearing the session and starting a new session again. So this new session means this time I have 3-dimensional data, X, Y, and Z. So it will be giving me a surface because I have a 3-dimensional data with me. So that's the surface fit which it has given me by default using the concept of interpolation, and the linear interpolation has been used. So that's a very rough surface. I can see that it's not a smooth surface. You can see the peaks here, the corner points here, but I'm just rotating this so that you can have a view of this. And then you can change from here the polynomial. From here also you can fit a polynomial, but for polynomial now you have to specify, because now there are 2 independent variables X and Y, and Z is dependent variable. So in X what degree you want, in Y what degree you want. So you just have to get a trade-off between these combinations, that which one gives you the good fit. So compare the errors and get your answers. So by looking at these fits, you can see which one is going to fit better. If I do the contour plot here, so that's the contour plot. So this contour plot is basically showing you the errors as well as, so it's actually 2D projection of our 3-dimensional surface. So the colors are actually showing you the magnitudes. So where Z value is higher, so there it is dark blue color. So that depends upon how the default contour is defined. So if you want to include let me see, there's an option of including a color bar. कहाँ पे होता है वो? That shows you the behavior, like the darkest color is the highest magnitude, or the other color is the lowest magnitude. So that depends upon what you want to see there. Let me just go back to this. Yeah. So the dark colors here, dark colors are basically the low magnitudes, and the orange color you can see on the yellow color is having the large magnitude. So that's how it works. So you can experiment with different polynomials and do that. So that's a surface fit example you can do, because many times we have a three-dimensional data and we want to get an equation of the curve accordingly. So it's a polynomial. In x is degree 2, in y is also degree 2. So you can see the terms with x and y are there, x square is there, x into y is there, and y square is there, and the constant term is also there. And these are the corresponding root mean square error and other things. So that's about all this curve fitting toolbox. Let's see whether we'll use it for some specific models to compare the data, or we can simply plot the data in directly in MATLAB also. We don't always need the curve fitting toolbox, but this is a very important toolbox you need to learn, and you can use this for a variety of functions. So now I'll be again asking you questions if you have. Anybody? I'll share this. Oh, my internet connection is unstable. Are you able to hear me?
Yes,
Yes,
ma'am.
ma'am.
Yeah, okay. So now I'll just give you a few things. I'll share, see this time because everything we are doing online. So the experiments which we'll be doing, you need to save their outputs as figure files, because more or less in every experiment the output is going to be some numerical value and a figure file. We'll be plotting the curves. So all those curves are saving as, you can save the figure file as the PNG and JPG file. We'll learn that in the next experiment, how to do that. So those you have to make a kind of a digital workbook for that, a report, kind of lab report you have to create. So you can create in Word or whatever software you use. So the first experiment, the name of it, that file I'll share with you. The name of the experiments is written, and then there will be a space to paste the pictures, to insert the pictures. So I'll share that draft file with you, and in that you just keep on editing and maintain it like your lab book. So that you keep on saving every week, and then I'll just have a regular look at it. We'll see how to do the file sharing on LMS and all, but for today it's okay. For this session you need not save these as outputs, because this was more or less just like an understanding of the toolbox. But if you want to write, or if you want to have a snapshots of these things, curve fitting toolbox, so you can name it as experiment 1 and do that. Otherwise formally our experiments are starting from next week, so you want to include this, then fine, otherwise that's okay. And one more thing is there. For this course we will be I'll be assigning you some projects for mathematical modeling. So you have to create your models, and at the end of the semester we'll have the project evaluation. So so for that I need to know your interest, that on what particular topic you are interested in. So I'll be doing that probably by next week, because अभी तो हमने कुछ पढ़ा नहीं है, अभी तो हम theory पढ़ रहे हैं. So I'll give you a few options out of which you can specify, choose your interest, topic of interest, and then based upon your interest I'll be combining you into groups and then assigning you the projects. अब वो कैसे execute होगा, even I have a question of that, because assigning in groups you should be working together, or otherwise I'll be giving you individual projects. So what do you say about it? Anybody has anything to say about it? Yes, Guneet.
Anything which is comfortable with you.
मुझे कुछ नहीं है, आपको ही करना है, because last time मैंने क्या किया था, there were 40 students, so I made a group of 4 students. There were 10 groups, so they did it collectively. But this time you all people are like working remote from home, so if it is okay for you to work as a group, so I'll assign groups, otherwise individually I'll be assigning you the projects. So you figure it this out, and by the time I figure out your topics of interest, you think about it, and then we'll see how to execute it. but that needs to be done. So make sure of that thing. And this recording of lab I'll share with you. You can do that, see the things later on your system. And yeah, anybody else has anything to say?
मैम टॉपिक्स हमें आपसे मिलेंगे.
हाँ, मैं आपको कुछ टॉपिक्स बताऊंगी, बट ये है कि अभी आपको वो लगेगा कि हम ये कैसे करेंगे, क्योंकि अभी तो आपको बिल्कुल भी अंडरस्टैंडिंग नहीं है, अभी हमने कुछ भी स्टार्ट नहीं किया है पढ़ना. सो आई एम जस्ट वेटिंग फॉर 1 more week and let's figure out some more topics. उसके बाद आई विल डू दैट पार्ट. बट मैंने आपको
ma'am.
पहले बता दिया कि ये करेंगे हम. And I'll be also giving you some assignments. वो असाइनमेंट्स को इवैल्यूएशन नहीं है कोई, इट इज जस्ट जो हम क्लास में पढ़ते हैं थ्योरेटिकली, या जो हम पर्टिकुलर मॉडल्स पढ़ेंगे तो उनके रिलेटेड क्वेश्चंस कैसे हो सकते हैं, राइट? बिकॉज हम जब क्लास में पढ़ते हैं वी कैन मैक्सिमम डू 1 or 2 एग्जांपल फॉर 1 मॉडल, बट रियल अंडरस्टैंडिंग कम्स व्हेन यू प्रैक्टिस प्रॉब्लम्स. सो आई विल बी गिविंग यू असाइनमेंट्स, so you practice that at home so that you have a confidence on yourself that I have understanding of this topic. So as such, that assignment is not having any evaluation, but the kind of questions I'll be asking there will be similar to what you are supposed to do in your exam. अभी वो नहीं पता है किसी को कैसे होना है, but still we do have a thing in our mind.
मैम एग्जाम से रिलेटेड कोई इन्फो कि मतलब ऑनलाइन होंगे ऐसे कुछ?
अभी तो कुछ नहीं है, अभी तो पिछला सेमेस्टर ही समेटा है हमने, तो अभी कुछ नहीं पता है. या सो जो भी होगा पता चल जाएगा आपको, ठीक है? एनीथिंग एल्स? Okay then, signing off. That was a wonderful session. Thank you for your attention.
Thank
Yes,
you, ma'am.
Yeah, okay, thank you.
Thank you.
Yes, thank you.